Only mode.
Good morning, everyone, and thank you for attending today's webcast, Simulation Driven Design with Autodesk Nastran In-CAD 2016. Our presenter today is Mark Lautenbach. He's a solutions engineer with Hagerman & Company. Before we get started, I want to let you know that you're in listening only mode. If you have questions during the presentation, just type them in the question panel on the right-hand side of your screen, and they'll be addressed at the end of the webcast. As you exit the webcast today, you'll be prompted to fill out a survey, and we ask that you take a few moments to fill that out. And with that, I'll hand things over to Mark.
Thank you, and excuse me. Good morning, everybody. Again, my name is Mark Lautenbach, a solutions engineer here at Hagerman & Company. Today, what we're going to do is I'm going to go over a little bit about the Autodesk simulation offerings, and in specific, this Nastran In-CAD software. Excuse me. So some things that we'll kind of take a look at as well. We'll want to take a look at some product design challenges that people may have, and how this whole digital prototyping concept works in conjunction both with the software that you may already have, as well as the simulation options that are available from Autodesk. Again, I'm going to dive a little bit deeper into the Autodesk Nastran In-CAD function and go a little bit about some additional benefits. I do have a couple what's the word I'm looking for? Demonstrations, product demonstrations I'm going to show you towards the end, and then we'll have some questions. So as we go, you've got your GoToMeeting panel on the side. There is a questions panel. Feel free to enter those questions as you come up with them, and I will address them many of them as I can towards the end of this presentation. I'll go through and look at the questions, and I'll try to answer them verbally so that everybody gets an idea of what some questions might have been. But again, that'll be towards the end. So first, are you facing any of these challenges? The need to make accurate design decisions without building multiple physical prototypes. Okay, you want to seek confidence in your simulation results, before investing resources, in design changes or new products. Maybe, product designs include a wide range of materials, not just your common metals. Okay, maybe you want to know, does any of that work? Maybe you've got some motion, and combination of multiple physical effects, design considerations. Maybe you got to do all of these different types of things. You want to avoid failures before it happens. You want to be able to determine the durability of your structures under repeated loading. Okay, maybe you've got something and you've got something applied to it, and then it goes away and it comes back and forth and back and forth. Okay. To meet those demands of that increasingly a competitive global market, a lot of firms face intense pressure to constantly innovate, reduce development cycles, and time to market. You want to avoid those in-field failures, but you also, of course, want to stay profitable. Okay. So there's a bunch of powerful benefits that a CAD embedded FEA technology can bring to your development process, and that's really what we want to go and talk about is this ability to do that type of stuff. This is a concept we've talked about many times, Autodesk digital prototyping. It's an innovative way for you to explore your ideas before you even build anything. Okay? It's a way for all of your team members to collaborate across many different disciplines, and it's a way for individuals and companies of all sizes to get great products into market faster than ever before. From concept through design to manufacturing, marketing, and beyond, the Autodesk digital prototyping concept streamlines this product development process from the start to the finish. So we want to bring in the simulation side of this into that whole digital prototyping concept. So what types of products do we have? Well, Autodesk has a whole slew of different products just for that purpose. Okay, you'll see things like, well, we're going to talk about Autodesk Nastran In-CAD today. Well, that of course includes this Autodesk Nastran solver. Okay, from there we've got things like simulation mechanical, we've got mold flow, we've got simulation CFD, robot structural analysis, okay, and flow design. So we've got a whole suite of different products available to us to simulate pretty much anything that you can come across. In the mechanical environment, okay, for manufacturing companies and mechanical products, we've really got a couple of different options. The Autodesk mechanical simulation offerings, they're all powered by the Autodesk Nastran solver. Okay, so the Nastran solver that's been around for years and years and years, which is an industry-recognized FEA solver that gives us accurate results for complex simulations. It's available in this Autodesk Nastran In-CAD, okay, which Nastran In-CAD gives us the CAD Embedded Simulation tools, okay, as well as, of course, in Autodesk's Simulation Mechanical, it's a complete mechanical simulation solution that predicts product performance, optimizes designs, and validates product behavior, well before we even go into manufacturing. Autodesk Nastran In-CAD software, that's a general-purpose FEA tool embedded into your CAD system. Okay, it's powered by the Autodesk Nastran solver, offers simulation spanning across multiple analysis types. Okay, so we'll be able to do things like linear analysis, nonlinear stress analysis. We've got different dynamics. We can do heat transfers. Okay, excuse me. This product is available. It's a network license. Okay, and it serves multiple CAD platforms. Okay, so we're not just limited to working in, say, Inventor. We can go in a couple different things. It's going to give a nice, consistent user experience, eliminating the need to understand or know different technologies. And since it's Nastran, it's going to give us a high range of high-end simulation results. So when we talk CAD Embedded Benefits and being a CAD embedded tool, what do we mean? Well, by offering an embedded workflow, okay, Autodesk Nastran In-CAD streamlines processes. Okay, how does it do that? Well, it helps maintain productivity by utilizing familiar environments. Okay, ease of use. It's going to eliminate need for multiple technologies by embedding it right into our software, whether it is Autodesk Inventor or even SolidWorks. So this tool runs inside of either of these products. Okay, so once you know your interface for the CAD program you're working with, this is just an extension above and beyond that to do all of these functions, which also means we've got true geometry associativity. That part geometry that we have in there, it's all configured and running with the simulation tools. Then when we go and make a change right there in our software, we don't have to switch from one software package to another. We stay in that same software package, make our changes to our geometry, go back in and rerun our simulation, get ourselves our new results. Okay. Excuse me. Again, it's a network license. So even if your company, your location, has seats of both Inventor and seats of SolidWorks running in different departments, you can have an individual license of Nastran In-CAD that, since it's networked, the guy in Inventor can be using at one point in time, and then when they're done, the guy that's using SolidWorks can then access that same single license. Okay, so we don't necessarily need to have, an individual license for every user. We can utilize network licensing to be able to utilize, a couple different software licenses that would then accommodate multiple users. Okay, again, whether it's in Autodesk Inventor or SolidWorks, that same license will work in both situations. It's powered by the industry-recognized general-purpose solver of Nastran, right? It's a general-purpose finite element analysis solver used for analyzing pretty much anything from linear to nonlinear stresses, dynamics, heat transfers. Okay, I talked a little bit about that. And whether it's for structures or mechanical components, the solver works with Nastran-compatible pre- and post-processors and offers real-time results and changes while solving. So while I'm solving something, I can get some feedback right away and be able to see exactly what's going on. But again, it is the true Nastran solver that's been around for years that people have been using, especially as you see there in aircraft, military environments, things that have been around for a long time. We can start with basic analysis for just exploring the viability of design alternatives and concept validations, and eventually we can move on to more advanced analysis, if and when those tools are needed. By using Nastran In-CAD, we have those capabilities here. It has that wide range of analysis capabilities from the basic things like just a standard linear static all the way on to nonlinear and heat transfer and even into impact and drop testing. Okay? So we can get into anything from simple things to more advanced items right there within, excuse me, within the same package. So again, some of the basic analysis functions that we have. Well, we've got linear static analysis. Okay, obviously that's probably the most common type of analysis that most people use, where we're going to determine stress, strain, and deformation, by applying some static loads and constraints. Okay, we can go into linear stress, thermal stress and deflections. We can get into buckling. Okay, we want to assess the stability under loads over time. Okay, maybe we want nonlinear stress. Okay, because maybe we've got some other things in that environment. We can do heat transfer. Okay, I want to see how heat transfers from one part to another in a linear function. Okay, thermal stressing. Okay, when we go in and we apply heat, well, that's going to stress our components. Well, we want to take a look at that. So again, nonlinear statics, nonlinear heat transfers. Okay, frequency responses. So again, and then the drop impact and drop testing. Okay, so we can go through and do any of these types of things with this Nastran In-CAD tool. Excuse me. So here I've got a few slides of some just different examples of product setups. Okay. So here's some advanced nonlinear finite models. Okay, just a simple structure here. Okay, maybe we want to take a look at buckling. Okay, you want to be able to simulate this lift arm and make sure that sure the structures themselves are strong, but maybe the material is going to buckle, even though you may not have something super intense that you might think that it would normally be fine with. Okay, nonlinear static stress, we'll take a look at this one here later. Okay, we've got a plastic shield here. Well, you want to be able to make sure that that plastic, being that the plastic itself, we want to be able to let it bend and deflect, but then stretch back to where it normally is before it actually breaks. So, we've got to get into some nonlinear type functions there as opposed to just your standard metals. Thermal transfer. Okay. I think I got the wrong caption up here because that's a brake, not necessarily a muffler mount, but that's okay. So, when you've got components rubbing against each other, how's that thermal, the heat transfer going to go from one part to the next part and so forth? So we can get into those. Okay. Excuse me. So in CAD, it brings that high-end simulation software functions to all of our engineers. Okay, by offering this package. Okay, it's a single product package as a network license. Okay, serves against multiple platforms. Right? We talked about how it can go into both Inventor and SolidWorks. And it can be that single license. It's that network license where we can then spread it and let multiple people use it. So what does that do? That reduces our initial cost of investment as well as the yearly maintenance. Okay. So it's going to help keep our costs low, which means we're going to end up being more profitable in the long run. Okay. So we've got ease of deployment, affordable package, and so forth. Now, we do have a whole community, this whole simulation community. You see there is a website, simhub.autodesk.com. This is an environment where it's set up for all of the end users to go in and ask questions, get answers, look up different things. There's a whole section. There's the simulation TV area where when you go there, there's all sorts of videos that have been created by users, some by the Autodesk experts showing the different functions and how to do different things with the software. So if you're you're coming across a situation that you don't quite understand how to do the setup inside the software, well, you might be able to find something on Simulation TV that then shows you that process and gives you a little bit of an option on how to, or an insight on how to do some of these functions. Okay, there's a whole series of learning resources on there. Like I said, the discussion forums and such, where you can go in and ask questions and get responses from the Autodesk experts that know the software, as well as other users that have been going through and using the software in the past. Other ways you can get some learning and some education, sure. Oops, I didn't want to go there. You know, we've got our authorized training center. Okay, so you can go to a training center like Hagerman and Company and go and take classes and figure things out. And then, of course, there's all sorts of online tools and such available to us. You know, if we go to Autodesk.com Learning, you'll find more. Autodesk subscription, and it's going to offer you the most convenient, modern, flexible way to purchase and access the software and any other functions that help you with this package as well. Okay, and there's a couple different subscription models that are available to you, and talking to your salesperson will get you that appropriate information. Why Autodesk? Well, you know, we've got a lot of stuff. Okay, basically is the name of the game here. Okay, where the Autodesk is leading the industry by bringing all of the tools that you need in a scalable, open, and cost-effective manner. Okay, whether you want to use cloud-based tools or you want to do some rental solutions, you know, Autodesk removes, you know, the barriers to help you make those great products. Okay, Autodesk has an extremely broad portfolio of products, so you know it's not just limited to one environment. So here I've got a couple other images here of just some companies that have had success utilizing the software. Okay, so here you see some that this company here become an important tool to examine their designs, you know, before any physical prototypes are made. Okay, and that's kind of the name of the game behind this whole digital prototyping thing is, hey, let's build something and see if it works before I invest the money into actually making a prototype to then verify it physically. Cessna's been using it. Okay, again, the Autodesk Nastran solver. Okay, it's been around for a while. They've been using it successfully, you know, and new functions, new elements have been developed to make it even easier for them. Okay. Here's another one for milling, grinding rollers. Okay. Bike examples, that's another good one. Okay, because maybe we want to make sure that, you know, it's not going to fatigue over time or something. You know, as we load and unload these different components, we want to make sure that they continue to function properly over, you know, over a set amount of time. And we'll take a look at a bike type example here. Again, some more components. Again, aerospace might be a big environment that you might need to get into. Okay, or anytime you've got something like this. Okay, again, just another example. So again, I just wanted to give you a couple different examples just so you can kind of see that, yeah, you know, there are a number of different companies that are using this and using it successfully. Excuse me. So now what I'm going to do is I'm going to switch over and we're going to get into some actual examples so you see the software. Now, again, this software, it is a separate product. So this will work both in Inventor, again, and in SolidWorks. It is a separate product that has to be purchased and it's installed and configured, but it runs right inside of your package. So the first one we're going to take a look at here is this suspension component from a bicycle. And basically what we want to do is we want to take a look at this mount here, okay, the crown of the fork, and we want to make sure that it's going to perform over time and it's not necessarily going to go in and break down, you know, under X amount of cycles or whatnot. So we're going to take a look at this, and what I'll do is I'm just going to go ahead and I'm going to minimize it down because I'm really only concerned about this one component at this time. Now we can go ahead and we can do full assembly and analysis and all all that kind of stuff, but we don't necessarily, we can go and do individuals and whatever it is we need at that point in time. It is a separate tool, okay? It is an environment. So when you install the software, you'll end up having inside of Inventor. Now, it could be just regular Inventor. It can be Inventor Professional. It doesn't matter because it is an add-on to Inventor, which then has the separate environment. So I'm going to launch the Nastran In-CAD environment, where you see I've got a new tab with all of the information that we need, and we just have to go through, and basically we're going to start from one side, and you kind of work your way across, as we go through the different functions. And the first thing we want to do is we need to make sure that we're in our right type of analysis. And for right now, yeah, I just want to do a quick, simple, linear static analysis. Okay. And then I need to go in and apply materials. Well, to this part, I want to make sure that we associate that material, this aluminum that we're designing it from, and say, yep, that's the material we want to work with. We're going to go in and add some information, like, I want to lock down these two mounting positions, okay, to say that they're not going to move, and then we'll put on a load. Okay, I'm going to load this with something rather large. Excuse me. Okay, so I'll say, 5,000 pounds in the what was that, the Y direction, going down, force going down. Okay, to go through and say, yeah, let's do something with a large scale and see how it reacts with just that piece of information. Now, in order to do any of these, we do have to break it down into smaller components, smaller different items. Okay, we're going to mesh our model into, smaller things that we can then go in and do the calculations based on. You see it meshes relatively quickly, and then we'll just run this to see what happens with this particular. Excuse me, a little under the weather today. So the simulation is done, and let's go ahead and take a look at some things. So you can go in, we can display, I want to look at the displacement and see how much total displacement there is. Let's hide some things and kind of give a little item here, and it's telling you how far is it going to move, right? Or maybe we want to look at, instead of displacement, maybe I want to look at actual stresses. Okay, so if I look at the stress, you'll see it says right now it's stress of 37 newtons, okay, which is probably, based upon this material, it's going to be well below what the yield point is. So I can go in and I can make some changes. Okay, I can go and I can make changes to this model. So let's go ahead and open it. Okay, again, I'm in Inventor, so I'm not switching from one software to another. And I'll go in and make some quick changes to my model here. Let's make this a little smaller. Okay, we'll make that a little bit different there. And I got one more that I'll make a change to here as well. Let's move around to the other side so we can kind of see really what we're doing. Let's change that here, and we'll make this a little bit thinner. Okay, so everything is a little smaller here. So now that we've made this smaller, because since we were so far away from the yield point, we figure we can start reducing our material, reducing the weight of this model. We'll come back here and we'll want to take a look and see, well, how does that work? Well, all we have to do, since we're in the same model, is we just have to update all of the Nastran In-CAD information. So it's going to update our mesh and such, and we'll just have to rerun the simulation. Okay. So now that we're rerunning it, okay, solution's complete. Let's go back in and take a look at that stress. And you can see now that we're up to 130. Now, that 130 might be closer to the actual yield point, or maybe it's slightly over the yield point. But, that's with a constant load. Maybe we want to see how it goes over time. Okay, so we don't necessarily want to go in and excuse me, just see it there, but maybe I want to take a look at fatigue. Okay, so instead of doing a linear static, we've got all sorts of other items, and you'll see we can do fatigue. If it's just sitting there getting vibrated, how long is it going to last over time? Or in this case, I'll just do a multi-axial fatigue to say, yeah, let's go ahead and run this fatigue setup. Excuse me. Okay. Now, when we do a fatigue setup and we're doing a fatigue study, we do have to go in and change some things as far as our materials. Okay, because we have to tell it that, yeah, you know, now we're doing some specific fatigue information, so we'll give some of those values. Okay, telling it, you know, based upon our stress and how many cycles, we've got some values that we already know that we'll fill in, excuse me, to achieve that information. Okay, how many cycles are we doing? You know, what is our calculation factors and so forth. You know, and as we enter things into fields like this, we can even see plot tables to see how things go, and you know, after so many cycles and so forth, what's going to happen with our stresses. Okay, so we can go in and change the actual materials, and then the loading itself. Okay, when we go into our loads, you know, we've got this load that's applied to it. Well, it's going to have history to it, you know, and that history is telling it that, you know, it's going to start with some values, okay, and we're saying that it's being applied with nothing, and then it's, you know, in half of a second or so forth, we're going to add a whole value, and then at 1 second, let's say, you know, it's going to have no load applied to it. So you're kind of telling it that it's no load, all load, no load, all load, so on and so forth, and we're giving it that information on how things are being applied. Okay. And then the only other thing that we need to do is we need to go in and say, well, as we're looking at fatigue, what information are we want to look at the fatigue over? Well, I want to look at the stress over time to see what kind of fatigue are we going to have, and then we just run it. Okay. Fatigue studies typically aren't too extremely long. Excuse me. So now that it's complete, we can see the life contours. Okay. In that fatigue, what kind of lifespan are we looking for? And you'll see that it's got a pretty high amount of life available to it. Okay. So you can see, you know, that it's, you know, 1 to the 10th power. That's about how many cycles we're going to have before this thing falls apart. Okay. So looks like we'll have plenty of time, you know, for this particular item, and have a little bit more confidence on whether or not this is going to work. Okay. So that's one example. Okay. So let's go ahead and get rid of that kind of stuff here. And then we'll move on to the next example. Okay, so the next example I have is that hedge cutter. I wanted to take a look at this shield here. Okay, the shield is made out of plastic. Okay, so same thing. I'm going to go back in. I'm going to take a look at this shield by itself. Okay, so I just got an environment that gets rid of everything else, and we'll go through the same process. Okay, this time we'll go into our in-CAD environment, and we're going to do a nonlinear analysis. Okay, because it is plastic. Okay, plastic is a nonlinear type of material. Excuse me. So we can do nonlinear static. We can go in and do buckling if we wanted to. So this one's a nonlinear static environment. Okay, we have to do the same thing. We have to apply the materials to the part. So I've got an ABS plastic, and I want it associated to this particular model. Now, because we're doing nonlinears, and because it is plastic, we do, like we did with the fatigue, we've got some properties that we have to change. Okay. Now we've got all sorts of different property type or material types, excuse me, whether it's isotropic, orthotropic, you know, hyperelastics, for different types of materials and rubbers. We've got the different types of options that we have to access when we're going through it. And then since we're doing nonlinears, okay, well, what type is it in here? Okay, you know, it's going to be a plastic type information, you know, and then we've got some values in here because we know what our stress values are and strain values are. Excuse me. So we can go through and add some different things in here if we needed to. Okay, our initial yield stresses and what the overalls are going to be. Okay, so we can enter in that kind of information. And from there, it becomes very similar to the last time. Okay, you're going to go in, we're going to apply some constraints to different surfaces. Okay, because this is where it mounts, so I'm gonna fix that down. Okay, we're going to go in, I'm going to apply a load on this back surface to say, yeah, you know, it's going to get hit by something. And we'll go in the X direction here. Yep, so we'll go 333 newtons in that direction. Okay. So then same thing, we have to mesh it, give it our values. Okay, we want a specific mesh size of something. Let it run a mesh. Excuse me. Lastly, what I'm going to do is I'm going to edit my nonlinear setup because we want to go in and have it do a series of different increments. Okay, because with nonlinear examples, it's going to apply the load, you know, and run the simulation, and it's going to go through and it's going to deform the part. Well, I want to keep it in that deformed state and then apply the load some more and keep it in that deformed state and apply it some more and some more and some more. And how many times do I want to do that? And that's what our setup does, is we tell it how many increments do we want to do it in. So I'm just going to say, you know, I'm going to say intermediate output, I'm going to turn it on. That way we can kind of see what's happening as it goes. And then I'll run it. Excuse me. Oh, and of course, I probably did something and made it fail. We're going to switch over just to make it a little bit simpler and go to something else. I'll come back to that one later. So here, I want to show two different examples, and that's why I'm kind of jumping past that. I've got two different things. We talked about this one, or you saw it in the slide, where I want to see about buckling of things. So same thing. Now, I've got two examples that I want to show as far as buckling, and I'm doing this to show and prove one item. Okay, we can do things both on solids, or we can simulate line elements. Okay, we don't have to have a solid to actually run these FEA simulations. Okay, so but first I'm going to start here. I'm going to start here because I want to show the actual process and how things are going to differ. So in this case, first thing I'm going to do is I'm just going to do another example. Okay, we'll do a standard linear static example. Okay, and in this example, again, I need to apply material. So these are going to be all, you know, mild steel. Okay, I got to make sure I grab all my components. Okay, so now that we've got our material set up, I want to go in, and since it's an assembly, we need to tell it how are these components tied together. Okay, so we need to go in and deal with some contacts. Now, we've got all sorts of different types of contacts. Okay, we can do separated contacts. We can for parts slide back and forth amongst each other and they don't separate, or maybe they just pull away from each other without sliding side by side, you know. So we've got a bunch of different things. But in this case, I'm just going to say make all of them, you know, bonded. I want to have all surfaces bonded to one another, you know, no problems there. I can go in and do my mesh. Okay, again, give my element size to be whatever it is that I want. Okay, so we're going to mesh our components, and then, you know, now I'm going to go backwards. Okay, so you can see that we don't necessarily have to do everything specifically, and the main things that you have to do. You have to tell it what materials we have. We need to tell it how parts are tied together. We need what type of mesh do we have. Well, now I'm going to go back in and do some constraints. Like this back surface I'm going to mount that and keep it fixed in position. Well, then I also have a spot here where there's something, there's a cylinder or something that's holding a pin state where it can then rotate on that axis and such. But in order to do that, I need to actually build some sort of a connection device in here. So we've got the ability to add what we call connectors. Okay, so I'm going to add a new connector. And the connector in there, you can see I can put rods, cables, springs, but it's a rigid body. Okay? Because I have two different locations, I need to create these rigid body connectors in the center there. Okay, and I can just change the display size. Okay, so I've got a rigid body connector at that point, and then I'll make another one over on the opposite side in the same sort of situation, but I don't want it to tie between the two. Let's delete that one. So there's a connector over on that side. So I've got these two connectors. Now that I have the connectors together, yeah, I can go in and constrain the 2 points because it's one connector in there. They're going to be end, so it can just rotate, in essence, translate on that axis, I should say. Okay, and then lastly, what I need to do, okay, I need a load. Okay, so on this face over here, I'm going to have a load that is going down in the direction of gravity, so it's in the Z direction. And I'll use something a little bit larger. Okay, load, got my constraints. We'll go ahead and run it. And you'll see that when I run this, being that I'm running a solution on a solid, it takes a little bit longer, okay, because we're getting into all the elements that make up all of those faces and all of the parts and all the solid information. So we've got a lot of elements that we have to go through. Okay, so it's going to go through and do a bunch of different things. Okay, there's a whole see there's 109,000 elements that are in this particular model. Okay, so this one really it takes about 4 minutes to run. So I'm going to stop there. Okay. Because instead of sitting here and waiting for 4 minutes and then going through and doing some other examples and waiting 4 minutes more, I'm going to switch over to this model. Same sort of scenario. I want to look at this particular model. Now this is a tower of some sort made out of structural steel. Okay, whether it's steel, round bars, angle irons, it doesn't really matter because inside of our environment, inside Nastran In-CAD, okay, I can go in and I can set up these different materials. Okay, and I set up materials on line elements. Okay, you see here under line elements, I can tell it what the cross section is supposed to be, and I can define that information. Okay, it's a box or it's a rod or a tube, panels. Okay, so we can go in and we can tell it what type of shape is it, and then what are the values. Okay, what's the overall. Okay, so in this case right now I'm starting with a 2 by 2 inch box with a 0.2 inch thick wall. Okay, and I did that on all the, as you see here in this image, any edge that's highlighted in blue gets this particular property, right? And then physical property number 2 here, the other components, these embedded type lines, are all cylinders. Okay, it's round bars that have a diameter of 1 inch. Okay, so we can go through and do that. So again, this is a linear static on just line elements. Now you'll notice when I run this, doing a line element base like this, it's going to run quite a bit faster, excuse me, than if we did that whole solid environment. So it should, I hope, start up here shortly. Oh, it's already running. Bear with me a moment. See, so far, again, if you have any questions, feel free to enter them in the chat panel, or the question panel, excuse me. I'll address those as we get to them. Close this guy down. Yeah, okay. Yeah, I still thought it was running over on that side. There we go. So you see now, this one it ran really fast. Okay, so now I can take a look at this. Okay, so let me take a look at this solution on this one. Now, when I come in here, you see it's showing me bar stresses. Okay, because that's the type of shape that I had. Let me turn off those other items here. And we can see the stresses on a particular model. And you know, just by looking at stresses, we're not going to know whether or not, like, you know, down here, can I tell if this bar here is going to buckle because of that? Well, with basic stresses, probably not. I can look at, you know, maybe I want to look at compressive stresses. Okay, I want to look at axial stresses. You know, we've got all sorts of different values we can look at. But again, this isn't necessarily going to tell us the story on whether or not it's going to completely buckle in this particular case. So we can edit our analysis and change. Okay, right on the fly. I want to change to maybe a linear buckling. Now with linear buckling, same thing with like when we did fatigue. We can give it a number of modes. How many times, you know, what different types of environments do we want to go through? Okay, so I'll say linear buckling. When we do a buckling and we switch from one to another, we might get a separate subcase. Okay, so it's actually doing multiple things. So I just need to copy some things over. Okay, and maybe now I'll run this buckling solution. Okay, again, really quick because we're in line elements. Okay, so if I take a look at the results here, what you'll start getting is you'll get this value here, which kind of is telling me how well is it functioning. Okay, it's kind of giving us a buckling factor and a safety factor. Okay, which we're pretty low. Okay, you know, we're under 1, which, you know, that safety factor, you know, we don't want to be anything really low like that. So sure, I can display it. You know, and when I display it, you can kind of see that, yeah, those two are really going off in la-la land there, and probably not a result that we want. So again, line elements, well, I can go in and make the changes really quickly to say, well, what's the cross section? I'll just increase it, make it a 3 by 3 inch bar with a slightly larger wall thickness. Okay, and let's even take the rod members. Let's make those rod members we'll go a larger diameter. We'll just say 3 inches in diameter, and let's rerun that. Again, line elements, very fast solutions. You know, great, obviously, in cases of excuse me, structural members. So you'll want to determine what do you want to base your information off of. And then now when I go in and edit that, you'll see that my factor is quite a bit larger, which is really kind of what we want to see. And when I display it, I'll be able to tell that, you know, it's really a much better solution. Excuse me. Okay. So at this point, I'm going to turn it over and take a look at some of the questions that are in the question panel. Excuse me. And one of the first ones that I see here is, you know, again, where can I find this add-on? Well, the add-on it's a separate purchase. Okay. You do have to purchase this as a separate license, and then once you purchase it, you download it, and you install it, well, then it is, again, a button inside of the environment section. You'll find the Nastran In-CAD button there. Okay. Yeah, we do not have to have Product Design Suite Ultimate. That's the word I was looking for. We do not need Product Design Suite Ultimate in order to use this. You can use it in any flavor of Inventor that you may have. So if you're using Product Design Suite Premium, yep, you could purchase this and have that as part of your tool set. Again, if you had SolidWorks, okay, you can use this Nastran In-CAD tool with SolidWorks. Or likewise, like I said, if you have a mixed environment where you have both SolidWorks and Inventor inside of your your company, yeah, that one license will then float and be able to be accessed by either person using SolidWorks or Inventor. Okay, let's see here if there's anything else. As of right now, I don't see any other questions. Okay, I'll give it a couple more minutes. Again, if you have any questions, please enter them into the question panel. Otherwise, shortly we'll be breaking. All right. All right. So if I didn't by chance answer all your questions, we will be documenting any questions that were left, and we'll get in touch with you on those. And if you do have any other ones, please feel free to contact your Hagerman representative, and we'll get in touch with you on those as well.
Okay, thank you for attending today's webcast and have a great day.